Hey, what's going on, guys? Let's do this problem right here. The first question is asking an object of mass 8 kg is attached to an ideal massless spring and allowed to hang in the Earth's gravitational field. The spring stretches 3.6 cm before it reaches its equilibrium position. If the system is allowed to oscillate, what will be its frequency? Now, here they have provided the mass and the stretch, right? And let's see how we can find the frequency using this information. And we know that for a frequency we can use this equation that f is equivalent to 1 over 2 pi square root of k over m, right? Now let's see whether we have all the information available. We have the mass, so with this part is not a problem, but here they have provided the stretch and we don't have any other information. And if you think about that, at equilibrium position, mg is going to be equal to kx. We know that f is equal to mg, f is equal to kx according to Hooke's law. This is going to be equivalent in equilibrium position. Now, using this information, we can find out our k value, right? K is going to be equivalent to mg over x. X is stretch, m is mass, g is acceleration of gravity, acceleration due to gravity. Now, mass right here is 8 kg times 9.8 over the stretch is 3.6 centimeter. We have to convert that one into meter, and that's going to be 0.036 meter, right? And if you calculate this one, you should get 2180 Newton per meter. Now we have the spring constant. Now we can plug this value in this equation to find out, to solve for f. Now let's write this equation a little bit top because we don't have enough space right here. Okay, so let's write this one right here. F is equal to 1 over 2 pi square root of k over m. Now we have this k, so this is going to be 1 over 2 pi square root of 2180 over the mass, that is 8 kg, right? And if you calculate this one, you should get 2.629 hertz. So the answer for this one is going to be B, because that is the answer that matches with this answer. Now let's look at the second question. An object that weighs 2.450 Newton is attached to an ideal massless spring and undergoes simple harmonic oscillations with a period of 0.640 seconds. What's the spring constant of the spring? Okay, here they have given the period, and period equation is going to be reciprocal of this one. Whatever this equation we used on top is going to be reciprocal because t is equal to 1 over f. Now let's write the period equation. Period equation is going to be 2 phi. Before we had k over m, here we are going to have m over k. So this is just reciprocal of this equation. And let's see, here they are asking for the spring constant. K is the one we are trying to find. We know the period that's provided. Mass is not provided, but this one, weight is provided. We know that weight is mg. F is equal to mg. So to find the mass, we can divide this f by 9.8 to calculate the mass, because g is 9.8. So that will give us mass f divided by 9.8. Now let's go ahead and plug the values. We have, before we do that, we have to rearrange this equation because we are trying to solve for k, right? So if you square both sides, this is going to give us t square is going to be equivalent to 2 phi square, 2 square phi square. So before I write this one, I can combine this together. T over 2 phi whole square. I brought this 2 phi to the other side. Now we take the square both sides. So this is going to be t over 2 phi whole square, and this square root will cancel this square. That's going to give us m over k. Now if you rearrange this for k, that's going to give us k is equivalent to m over t over 2 phi square. Now let's plug the values. So m is 2.450 divided by 8 because this is in Newton. We had, 9.8. 9.8 is acceleration due to gravity. So this is going to be 9.8 right here. And then the period is 0.640 divided by 2 pi and then square. And if you calculate this value, you should get 24.09 Newton per meter. So according to this one, the answer is going to be E, because that one matches with this one. So the answer for this question is E. Now let's go ahead and do this third question. Third question, we have a 2 kilogram block on a frictionless table is connected to two ideal massless springs with spring constants K1 and K2 whose opposite ends are fixed to volts as shown in the figure. What is the angular frequency of the oscillation if K1 is equal to 7.6 Newton per meter and K2 is equal to 5.0 Newton per meter? Now to find this one, we had to use the angular frequency equation, that is omega is equal to square root of K over M. So here we have two spring constants, right? So in this case, what we had to do is we had to add them together. So the total K is going to be K1 plus K2. And if you add them, 7.6 plus 5, that's going to give you 7.6 plus 5, that's going to give you 12.6, right, Newton per meter. Now we can go ahead and plug in this equation. So this is going to be 12.6 divided by the mass, that is 2 kilogram. And if you calculate this one, you should get 2.5 radians per second. So the answer is going to be C. That's how we do this kind of problems. I hope you guys find this video helpful. See you next time.